Today we are going to discuss some of the problems on transforms analysis of LTI systems, transfer function, stability and causality. So first problem, design a causal discrete time LTI system with the property that if the input is x of n is equal to half to the power n into e of n minus 1 by 4 into 1 by 2 to the power n minus 1 into e of n minus 1. Then the output y of n is equal to 1 by 3 to the power n into e of n. Determine the impulse response h of n and the system function h of z of the system that satisfies this condition. So it is given x of n is half to the power n into e of n minus 1 by 4 into half to the power n minus 1 into e of n minus 1, and y of n is equal to 1 by 3 to the power n into e of n. Equation number 2. Taking the transform of equation number 1 and 2, we get x of z is equal to 1 divided by 1 minus half z inverse minus 1 by 4 z inverse divided by 1 minus half z inverse, which is equal to 1 minus 1 by 4 z inverse divided by 1 minus half z inverse, and y of z is 1 divided by 1 minus 1 by 3 z inverse. Then h of z is equal to y of z divided by x of z, which is equal to 1 minus half z inverse divided by 1 minus 1 by 3 z inverse into 1 minus 1 by 4 z inverse. Using partial fraction, we get h of z is equal to minus 2 divided by 1 minus 1 by 3 z inverse plus 3 divided by 1 minus 1 by 4 z inverse. And taking inverse z transform, we get impulse response h of n is equal to minus 2 into 1 by 3 to the power n into e of n plus 3 into 1 by 4 to the power n into e of n, which is equal to 3 into 1 by 4 to the power n minus 2 into 1 by 3 to the power n into e of n. A causal system is described by the difference equation y of n is equal to y of n minus 1 plus y of n minus 2 plus x of n minus 1. Find the system function h of z. Plot the poles and zeros and indicate the ROC. Also determine the impulse response of the system. That is given y of n is equal to y of n minus 1 plus y of n minus 2 plus x of n minus 1, or y of n minus 1 minus y of n minus 2 is equal to x of n minus 1. Taking Z transform on both sides, we get y of z minus z inverse into y of z minus z to the power minus 2 into y of z is equal to z inverse into x of z, or h of z is equal to y of z divided by x of z equal to z inverse divided by 1 minus z inverse minus z to the power minus 2, which is equal to z divided by z plus 0.62 into z minus 1.62. Since the system is causal, ROC must be outside the outermost pole, that is z is equal to 1.62. Then we can draw the zeros and poles, real of z, imaginary of z, so 0, so 1.62, so 0.62. So this will be the ROC for the given problem. We know that h of z is equal to z inverse divided by 1 plus 0.62 z inverse into 1 minus 1.62 z inverse, which is equal to k1 divided by 1 plus 0.62 z inverse plus k2 divided by 1 minus 1.62 z inverse. K1 is equal to 1 plus 0.62 z inverse into h of z at z is equal to minus 0.62, which is equal to minus 0.45, and K2 is equal to 1 minus 1.62 z inverse into h of z at z is equal to 1.62. We get 0.45. Then h of z is equal to minus 0.45 divided by 1 plus 0.62 z inverse plus 0.45 divided by 1 minus 1.62 z inverse. Then taking inverse z transform, we get h of n is equal to minus 0.45 into minus 0.62 to the power n into u of n plus 0.45 into 1.62 to the power n into u of n. Determine whether the system is causal and stable with h of z is equal to 1 plus 2z inverse divided by 1 plus 14 by 8z inverse plus 49 divided by 64z to the power minus 2. It is given h of z multiplying and both numerator and denominator by z square. We get h of z is equal to z square plus 2z divided by z square plus 14 by 8 z plus 49 divided by 64, which is equal to z into z plus 2 divided by z plus 7 by 8 whole square. Therefore, the location of both the poles z is equal to minus 7 by 8, since all the poles are lying inside the unit circle in the z plane. The system is both causal and stable. Next problem, a LTI discrete time system is given by h of z is equal to 3 minus 4z inverse divided by 1 minus 3.5z inverse plus 1.5z to the power minus 2. Find the ROC of h of z and determine h of n for the conditions the system is stable and the system is causal. It is given h of z is equal to 3 minus 4z inverse divided by 1 minus 3.5z inverse plus 1.5z to the power minus 2. By partial fraction, we get h of z is equal to 1 divided by 1 minus half z inverse plus 2 divided by 1 minus 3z inverse. Therefore, the location of poles are z is equal to half and 3. So, first condition for the system is stable, its ROC must include unit circle. Therefore, ROC is between half and 3, and taking inverse Z transform, we get h of n is equal to half to the power n into u of n minus 2 into 3 to the power n into u of minus n minus 1. Second condition, for the causal system, the ROC should be outside the outermost pole. That is, ROC is given mod z is greater than 3, then h of n, by taking inverse z transform h of n, we get half to the power n into u of n plus 2 into 3 to the power n into u of n.